Hi everyone. Welcome back to Real Estate Redefined, a web series brought to you by Cisco's Hybrid Work Center of Excellence team. My name's Murray, and I'm joined by my colleagues Ansar and Mike in delivering this episode to you today. In our 8th episode of the web series, we will be discussing IoT and OT endpoints. As a recap of the previous episode, we discussed information and security operations. For those returning visitors, thank you so much for continuing to watch and learn from our web series. We hope these episodes are helping you and your colleagues understand what is possible with technology and what the future may hold for the built space. For those who are just joining us for the first time today, please make sure to check out our YouTube to watch the previous episodes in the series. Now let's jump into episode 8. In today's episode, we will be focusing on IoT and OT endpoints within the modern workplace and smart buildings. We'll be covering several key areas. First, we'll be discussing OT use cases for IT devices. We'll then cover some typical OT devices. Our third topic will be on 90-watt endpoints. And finally, we will discuss IoT workflows within the modern office. Before we get into the bulk of today's session, I'd first like to break down what we mean when we talk about IT or OT. IT stands for information technology. We can think of it as being focused on connectivity, specifically of people, devices, and applications running on a network. OT stands for operational technology. Operational technology is focused on connectivity for and control of building systems. It's really about the solutions that are used to monitor and control devices, processes, and events within a building. These systems are essential to making sure a building is operating efficiently. From an industry trend perspective, we are also seeing that the OT side of the network is drastically expanding in size due to new wired endpoints being brought online, while on the IT side of the network, we're seeing a shift towards less overall wired endpoints due in part to a major shift towards wireless first for end-user connectivity. Now I'll hand it over to Mike to talk a bit about the smart building ecosystem.
Thank you, Murray. As we start to dive into the endpoints associated with smart building applications, we're seeing a shift from information technology to operational technology ownership. On the right, we see devices that are typically managed by the IT staff within an organization. On the left, we can see this concentrated shift for building systems, servers, and applications moving to the operational technology stack. These previously siloed systems are rapidly being absorbed into the converged network environment. Here, we dive into the smart building ecosystem and how cloud components interface with the building systems and each other. First and foremost, we want to ensure that all edge devices have connectivity over IP for a common communication framework and protocols. This can easily be achieved using the Catalyst switching portfolio to connect endpoints within the access layer. Using the IoT container app, data from wired and wireless devices can be ingested into Cisco spaces. We can clearly see the flow of data from the various IT and OT subsystems. For IT systems noted, data is transmitted directly to the cloud instance of Cisco spaces. For OT systems, sometimes we will need to leverage an on-premise gateway and possibly a subsystem cloud instance. Finally, open APIs should be used for integration between systems using a common publish and subscribe ontology. This ensures seamless integration between systems using a common language.
Thanks, Mike. Now, something that needs to be considered with the increased number of devices being added to the network is, what does my physical infrastructure look like? We've talked about this briefly in previous episodes related to IT closet or the IDF rooms, and when it comes to the cabling, it's very similar. The increased cabling, while seemingly significant on paper, does not have any negative effect on the building of a space. In fact, what we see is that with more devices connected to the network in this way, the scope is actually easier to organize because a low voltage contractor can pull cabling for IT, OT, and IoT endpoints at the same time. The pathways by which you run your IT cabling will be primarily the same for your OT and IoT devices, with a slight difference in how the cabling ends up branching out from the main bundles connecting the space. Now, looking at some of the different devices that are typically referred to as IT devices, What Cisco is doing with these devices is enabling them to solve problems outside of just IT-related use cases when used in conjunction with Cisco spaces. Our wireless solutions can be used to provide an understanding of occupancy and utilization of space while also acting as a gateway for BLE and other IoT devices. Cisco collaboration solutions can help understand the occupancy and utilization of a room while also providing basic air quality information from the space. Looking at our switching portfolio, we see these as a means to converge typically disparate IT and OT systems, while also providing an understanding of the power usage of certain devices and systems. While not every org will consider these as IT endpoints, the Meraki portfolio of cameras and sensors enable the ability to understand entry and exit to space and more granular air quality information respectively. Last but not least, we have third-party sensors that when combined with Cisco networking or wireless, enable a myriad of other use cases such as asset tracking and more granular location services. What you are seeing here is a screenshot of one of our video devices in a diagnostic mode called Speaker Track Diagnostics. This view allows us to see how some of our awesome features actually work on the devices, and as its name implies, is a tool that is primarily used for troubleshooting issues with the device. On this view, we can see how the device counts people within a space by recognizing faces. We can see how the device makes use of the beamforming mics to understand distance of audio, which when combined with the facial detection allows the camera to frame around just the speaker if so desired. Now I'll hand it off to Ansar to talk a bit how we visualize and capture occupancy from other solutions.
Thanks, Murray. One of the key benefits and the features of Cisco Spaces is its ability to provide valuable data and insights through real-time occupancy and space utilization monitoring. Similar to what Murray talked about, leveraging collaboration endpoints for detecting presence as well as also counting people in the room, Cisco wireless infrastructure can also be used for getting occupancy data across the floor and helps you identify the most as well as least utilized space in a building. When you integrate Cisco's wireless infrastructure with the Spaces platform, it offers an occupancy heat map on a 3D floor map, allowing you to visualize where people are located on the floor. This map provides you details like capacity, occupancy percentage in real time, or lets you rewind to review the activities over the past 24 hours. Now, let us discuss another method for gathering floor occupancy data at macro level. While cameras in workspaces are primarily deployed for security monitoring, Cisco Meraki MV cameras offer several additional IoT capabilities beyond basic security use cases. One notable feature is their ability to provide valuable insights by detecting occupancy in real time. These cameras can be configured in multiple ways. In line crossing configuration mode, people walking in and out, typically at entry/exit points, are detected and counted. Another method is area occupancy configuration, which monitors occupancy within a specific region of interest. And additionally, with the third generation fisheye cameras like the MV33s and MV93s, advanced people counting using a custom machine learning model significantly enhances the accuracy level. In short, it is noteworthy that we can utilize Cisco infrastructure such as like collaboration, wireless, and Meraki as sensors to gather data and insights. This minimizes the dependency on duplicated overlay infrastructure that typically built using third-party devices and sensors, and thereby you reducing the overall cost, enhancing the security, and streamlining the operations.
Thank you, Ansar. Here, we see typical OT subsystems and their associated use cases. Subsystems include, but are not limited to, central and terminal HVAC equipment along with their respective temperature controls, lighting and lighting control systems, electrical distribution and metering, electronically actuated plumbing and gas valves, as well as third-party sensors. These systems drive various smart building use cases, such as more granular control through a deeper sequence of operations, thermal comfort and environmental monitoring, energy optimization and usage insights, occupant health and wellness, productivity, occupancy analytics, tenant billing, and building monitoring and optimization.
Thanks, Mike. In modern business operations, the number of building OT devices needing connectivity is rapidly increasing due to the high demand for data-driven insights, optimization, automation, and energy-efficient as well as sustainable environments. Typically, buildings' OT systems comprises IoT sensors, light, window shades, security cameras, HVAC systems, and various other endpoints for base building services and other security as well as workspace transformation components, including what Mike mentioned in his previous slide. Supplying and managing power for thousands of these endpoints can be a significant challenge, often involving you running line voltages or providing battery-powered solutions at scale. Power over Ethernet, or PoE, is groundbreaking technology that transmits both the data and power through a single Ethernet cable, and these solutions can be leveraged to overcome these challenges. Particularly, Cisco's UPoE Plus solutions, capable of delivering up to 90 watts of power per switch port, unlocks new possibilities in modern buildings. With the UPoE Plus capable switches running in a converged architecture, it truly overcomes the challenges in powering thousands of those endpoints at scale, helps organizations to save on cost, promotes sustainability, and also simplifies data collection and the overall operations of various subsystems in a building that used to operate in siloed manner.
Thanks, Ansar. Now, why is UPoE Plus more impactful for the built space compared to UPoE? It drives greater efficiency of PoE-powered systems by allowing you to power more things from a single port. Looking at the comparison for lighting, we are going to use a linear fixture as an example. From a UPoE or 60 watt port, we are delivering 51 watts to the endpoint or PD at 100 meters. This 51 watts can be used to power up to 12 linear feet on a typical 4 watts per foot linear fixture, or can be broken up into 3 4-foot sections with separate drivers. With the UPoE Plus or 90 watt port, we are delivering 71.3 watts to the PD or power device at 100 meters. With this wattage, we are able to power 17 linear feet of fixture, which again can be broken up similar to what we saw on the 60 watt port. While 5 additional feet is not too significant for a single port, when we multiply that across a stack of switches, we are seeing much greater efficiency of the system, thus driving the cost of the solution down. Now, taking a look at the same comparison for a PoE-powered shades, we see that we can only power a single DC motor covering 2 shade or window bands with a UPoE port. But with a UPoE Plus port, we can power up to 2 different DC motors, each with the ability to cover 6 shade or window bands. This is a massive difference when it comes to shading, with a 6x scale improvement due in part to the efficiency of the newer 90 watt PoE gateway from Meko. Again, we see efficiency improving and in doing so driving costs down. Here we are seeing at a high level how the data from different solutions makes its way into Cisco spaces. For data from both Meraki and collaboration devices, the information flows from the endpoint to its respective cloud and then via APIs makes its way into spaces. From Catalyst products and third-party devices, first the Spaces 3.0 connector is spun up. Once this is done, you can onboard switches to capture telemetry data from them and deploy the wired gateway app to the switch to allow flow of traffic from endpoints into spaces. You can also onboard your wireless deployment and deploy the wireless gateway to the WLC to get occupancy information and data from third-party devices respectively. While this does not cover all the steps that go into deploying Cisco Spaces, it gives a high-level view of some of the steps that need to be taken to get data from endpoints into the platform.
We will now examine the architecture of indoor IoT services. Each component has a specific set of functions. For the Catalyst 9800 series wireless LAN controller, it will receive the access points BLE configuration from the connector via cloud over netconf and sends the configuration to the AP via CapWAP. Confirmation of the configuration push to the wireless LAN controller is done via TDL. The wireless LAN controller also pushes gRPC-related configurations to the AP when IoT services streams are started. The AP functions are as follows. The BLE radio is used in base or advanced BLE gateway configuration. The access points BLE scan data is sent to the connector over gRPC, then sent to the cloud. Access point also sends its gRPC status to the wireless LAN controller periodically over CapWAP. DNA Spaces receives configuration from cloud and pushes it to the wireless LAN controller, and also receives BLE data over gRPC and sends to the cloud. The ports used on the DNA Spaces connector are port 8000 for gRPC. Each AP will create a separate gRPC connection. Wireless LAN controllers use port 8004 on connector for TDL. Each wireless LAN controller will create a separate connection. As we walk through the wired gateway's role in the smart building, we can see how data is flowing from the various endpoints into Cisco Spaces and partner applications. A vendor node handles the connection of proprietary sensors to the Catalyst switch via ERSpan. From here, the IOX application on the Catalyst switch hands off to Cisco Spaces using the Spaces connector via gRPC, unidirectionally passing off to the cloud. The Spaces connector can then talk back to the Catalyst switch via netconf as needed. Here we covered the means and methods of collecting third-party endpoint telemetry using Cisco access points and switches. We can see the various BLE and IoT devices connected both wirelessly and wired, flowing data to Cisco Spaces. Our partner application store has several approved vendor solutions that integrate seamlessly with Cisco Spaces. It only takes 3 steps for a process that was previously cumbersome and time-intensive.
Thanks, Mike. The Device Manager dashboard within Cisco Spaces allows an administrator to see an overview of all IoT devices with a single pane for devices from any single vendor, including details like the model and firmware version of said device. From this dashboard, you are also able to configure any beacons you may be using in your space and capturing data from to be brought into the Spaces platform. It's important to note that only devices that are claimed in an individual Spaces account will be available from this dashboard. Looking at the IoT applications of Cisco Spaces, we can see that the solution helps enable business outcomes across industries. Customers can make use of different tags and beacons in conjunction with the platform to accomplish their goals. Some examples of these are using tags from contact and menu to track assets within a space, track environmental monitoring with a multitude of different third-party devices, keep employees safe with real-time notification and location updates from personnel and risk tags, and get even more understanding of space utilization with beacons and PIR sensors, which could also be on your PoE lighting platform. These are just a few of the amazing outcomes that can be achieved when you combine Spaces and IoT devices. Thank you all so much for joining us for today's episode of the web series. If you just joined us for the first time today, please make sure to check out our previous episodes on YouTube. If you enjoyed today's episode, make sure to register for future episodes of the series. Please make sure to come back next month for episode 9, where we will be covering telemetry and APIs.